a speaker from New Relic, and he is Zameer Fouzan. He is a senior developer relations engineer from New Relic, as I said. He is going to present his talk on top 5 things to know running OpenTelemetry on Kubernetes, where he will cover the rise of OpenTelemetry, its core concepts, and different components such as instrumentation, collector, operator, and more. So handing over the stage to Zameer.
Good morning, everyone. Welcome to KCD Mumbai. My name is Zameer. I'm a developer relations engineer at New Relic. Today, I'll be talking about top 5 things you should know about OpenTelemetry before you run it on Kubernetes. First, we'll see the rise of OpenTelemetry. OpenTelemetry is one of the fastest growing projects in CNCF space, and it's right behind Kubernetes. There are a lot of interest and contributors in the community, and there is a lot strong interest in modern observability that we are seeing. There is also a lot of interest in GitOps, which is where Argo CD and Flux is going strong, and that is also right behind OpenTelemetry, and CNCF projects are picking up pace. So there was a report from Gartner that there is a requirement for enhanced support for open standards, which is what OpenTelemetry, eBPF, and Grafana are working towards, and they have this enhanced open standard support already. So OpenTelemetry is an incubating project in CNCF. It was formed by merging 2 of the famous open source projects, which was OpenTracing and OpenCensus. OpenTracing comes from the land of Zipkin and Jaeger. If you have used that was using the concepts of OpenTracing. And if you are using Prometheus, you're already following the concept of OpenCensus. These 2 projects were combined, and today it's known as OpenTelemetry. So the goal of OpenTelemetry is, it is vendor agnostic. That means if you're using OpenTelemetry to instrument your application or services, you are not getting logged into any specific vendor. That means you are in control of your applications, your telemetry data, and all your services. It is setting a standard of how we collect our telemetry and how we control our telemetry data from all our application and cloud native services. The best part of where the community is interested is you can choose the backend for your telemetry data. That means you are in control of what observability platform you want to use. It can be open source, it can be a specific third party, and if you don't like it, you can always switch to a better provider. Now, why is community so much showing love to OpenTelemetry, and why are there so much interest in OpenTelemetry that's rising? So these are 4 key facts and 4 key concepts where OpenTelemetry is good. The first one is ubiquity. So OpenTelemetry is striving to promote better coverage for cloud native application for instrumentation. That means if you're using cloud native application, microservices or distributed, OpenTelemetry has great support, and you can start your observability journey with confidence that you're able to extract good data from that. Second, it's vendor neutral. As I mentioned, it provides you flexibility of what platform you want to use. You're not getting logged into a specific vendor that happens with traditional third-party tools. Third, and which is also important for going forward or re-architecting and modernizing your application, is interoperability. If you're already using some form of tracing or some form of observability, let's say it was Zipkin or Jaeger, it can play nice with OpenTelemetry already, because OpenTelemetry provides support where you can use your existing solutions and connect your new applications, and they'll play well together. So you do not have to worry on that front. And fourth thing, which is the most important and something I like, is configurable. OpenTelemetry provides you options to be in control of how you want to collect your data, what data you want to keep, and how you want to process your data. And it provides extensive configuration for each aspect, from the collection point to exporting and in between before you export your data. There was a report from Gartner 2021 that by 2025, at least 70% of new cloud native applications will use some form of open source instrumentation, which is where we are seeing OpenTelemetry really growing. So let's just all jump on the train for OpenTelemetry and start utilizing it. Why not just, for our new application, add the OpenTelemetry and start our journey? But what do we need to be mindful of? What are the caveats that we need to think of? How do we plan? So let's look at some design consideration. I'll use the cake example here. So on the right hand, I have end product, which are New Relic agents or any third-party agents that we have today. And on the left-hand side, it's OpenTelemetry. So on the right hand, consider it as you want to have a cake. You go to a bakery, you know what cake you want. You just place an order, you get the cake, ready to eat. And that's the expectation. I want to have a cake, I'll go buy a cake. And we have varieties of cake available. It can be strawberry, it can be cheesecake, and that's what most languages are supported from third-party agents, and they're ready-made. But with OpenTelemetry, it's giving you an option to be a master chef. You get to customize what you want. You have your own preferences. It can be gluten-free, it can be egg-free, or an eggless cake. So OpenTelemetry provides you an option where you choose your ingredients. You choose how you make it. When I say you choose, OpenTelemetry has SDKs and libraries where you pick and choose of what data you want to instrument, what is important to you, because you know your application and services and you know what is important. The support with customizable and OpenTelemetry libraries today is, with Java and .NET, is actually stable today. As of yesterday, I checked that all the APIs are stable. Next is Node.js and Python in the list. They are almost stable. Not that community is not interested in new cool kids, which is Go and Rust. We do have support for that as well in OpenTelemetry. Thing is, it's less stable. The reason being, Java and .NET are widely adopted, and to cater to that with a wide audience was the first goal of OpenTelemetry, and they have done it right. So before you start your planning and implementing OpenTelemetry with your applications, here are 6 questions that you need to ask yourself or have an answer to before you actually use OpenTelemetry. The first one would be, do you understand the difference between monitoring and observability? You really should understand the difference that observability is not just an extended form of modern monitoring. It's just not up or down, red or green. Observability is much more. You need to have deeper understanding of what observability is and what your end goal is with observability. Next is, you should understand the core of telemetry data, which is metrics, logs, and traces. If you think, or whoever the decision maker is, thinks that with only metrics and logs, you can get all the observability and you can solve all your problems, that OpenTelemetry might not be right, because while metrics provides us good details of what the spike was or what the drop was, and logs are expensive, it cannot give us all the information to solve the problems. We do need all these 3, and we need to understand which data type is going to be helpful for us. Traces is something OpenTelemetry is very strong with, and that's where OpenTelemetry shines. So if you have distributed application or microservices, traces is something you should focus on, because in your observability journey and distributed application, you need to have the lowest downtime possible, and traces is going to help you there. Third one, as I mentioned, tracing is widely deployed. So if you have microservices plan, definitely explore and understand tracing, the spans, how it's constructed, and what data you require. Fourth and most important with OpenTelemetry especially is manual instrumentation. If you want to be actually in control of your data, you need to understand how to actually manually instrument your application. You need to have good understanding of your own application as well as what you want to capture. And together with that is the fifth question, is your app friendly to manual instrumentation? If you're using something third-party or off-the-shelf applications, you may not be in control, and that becomes your gray area. So if your application is friendly to manual instrumentation, that's good. You're ready for OpenTelemetry. Last but not the least, the sixth question is your environment tolerant to change? yes, OpenTelemetry is great, but it's growing, and with any other evolving products, we see a rapid change. So you might need to change some libraries or SDKs that you're currently using, or you might need to add something that will change your environment. So are you in control of your environment? Can your environment actually handle the frequent changes? You need to be really mindful of these 6 questions before you start using it. And you should include these questions in your planning journey already. I want to bring your attention to the chart on the left. So that's a hype cycle report from Gartner 2022 that says the understanding and maturity of industry of the expectations of different technologies and concepts. If you notice on the top, on the red arrows, we have observability and distributed tracing. The industry already understands observability and distributed tracing. They know what to expect. They know if something fails, what's the troubleshooting guide, and what to do. And OpenTelemetry is still picking up the pace. But there's a lot of interest and it's picking up the pace, which is good, because whenever the OpenTelemetry reaches the peak and industry is widely adopting it, OpenTelemetry will be mature and ready for all the applications. So that was design consideration. Now getting into the action, which is instrumenting our application. So before we start using instrumentation, you need to understand the different components of OpenTelemetry. So these are some of the concepts, core concepts of instrumenting any application, and that is common across all the languages and services of cloud native. First thing is semantic convention. This is what provides specification for all libraries and SDKs across languages of how the nomenclature, how the HTTP calls, or how the collection should work. So semantic convention is unique and unified across all SDKs and languages. Second one is API, so different APIs for data types like tracing, metrics, and logging. So OpenTelemetry provides APIs for each of these data types. You should be mindful of what API you want to use and what data you want to collect. Third is SDK. Each language have their own implementation of SDK, but they follow the specification provided by the OpenTelemetry. And most languages, sorry? This issue is not part of the demonstration. Yeah. Okay, we are back. SDKs. So going back, most SDKs for any framework and libraries in modern day today, which it could be .NET or Java, Spring Boot, or Node Express, they already have good SDKs where they support auto instrumentation, and you can get started quickly with those SDKs. The last one is OTLP, which is an important part of OpenTelemetry. Once you have all your data instrumented and collected all your telemetry, we need to send it to a backend because we cannot store it in our application, obviously. So there is a protocol which is OpenTelemetry protocol, also short form for OTLP. We can use this protocol or an endpoint or a collector, which I'll be talking about. We can use this protocol to send all our data. And most SDKs have the implementation. You just need to point it to the right backend where you want to send your data. Let's see how it looks like. So in this example, we are using a community provided OpenTelemetry SDK for Java. It's a simple Java application, and we are using automatic instrumentation. If you focus on the red highlighted part, you'll see that only with few lines of code, we are able to start instrumenting our Java application, and we'll see all the collected data. And on the right-hand side is the manual instrumentation for the same application. Yes, at the first glance, there's a lot of code compared to the automatic instrumentation. But think of a scenario where your application goes down and you're going through your telemetry data. you actually have to dig all the data before you finally pinpoint where the issue was. But if you are using manual instrumentation, you know what data you have sent, what attributes you have added, how you have constructed the spans. So at the first glance, you'll be able to identify, okay, this is happening at this specific point in the code. So manual instrumentation really gives you that kind of control. And you can add as much as metadata you want, which is helpful for you in debugging. Now, once we have instrumented our application, this is what we get. I exported it to a New Relic backend. Again, it's up to you which backend you want to use. It's free. And here, what we are seeing is our trace from our application and all the individual spans. So each span provides me the data and metric of what the data was collected from my application. And I can dig deeper into this, and if I have used manual instrumentation, I can add all this data, which is my metadata and custom attributes. Now, this is where really OpenTelemetry shines. You add your data. This will help you with your mean time to detect and mean time to resolve in case of an issue, which is MTTD or MTTR for short, if you're familiar with it. And let's say in a distributed application, once you have added this, it really brings down your troubleshooting period, and your ops team or SRE team is really going to be happy. Next thing is, once we have all our data instrumented applications and services, we are going to export it. So collector is an important piece with OpenTelemetry and even with Kubernetes once you want to instrument it. So this component you need to understand really well because this kinds of act as central piece or a proxy to which we will be sending our data. It has three different parts, which is receiver, processors, and exporters. So receiver is basically how we get the data from our application. It can be push-based or pull-based. And processors is a central piece as part of collector, where you decide what data you want to keep. If you want to process your data, you want to add data, or you want to drop data. Not all data collected can be helpful. So with processor, you get to choose how you want to send the data, what data you want to see. And lastly, the exporter as part of collector. You choose what backend you want to send, and this is supporting OTLP protocol, as well as if you're using Jaeger or Prometheus today, collector is able to collect the data from that as well. Now, what about who are already using Prometheus and Grafana? It's a favorite tool for many, so what about that? So the support is existing with OpenTelemetry, but it is experimental. If you want to explore that front, definitely read through the official documentation of OpenTelemetry as well as Grafana. Since it's an experimental phase, you really need to be mindful of that. Now here's an example for collector. In my collector.yaml file, in this example, I'm scraping all the host metrics and CPU, memory, and disk. And after adding the configuration and I run this collector, I'm able to extract and scrape the metrics from the host. On the right-hand side, in the example, if you see, once all this data is exported, we are able to find the trend chart for memory utilization. So it's just that simple. In the simple collector configuration file, you just add what you want to collect from the host, and on your back end, you'll be able to evaluate the data. Now, with collector and the processing part, there comes an important piece. Going back to the tracing part, which is where OpenTelemetry is good, you need to be having understanding of what trace data you want and how you want to manage your trace data. So generally with tracing, we have two concepts, which is head-based sampling or tail-based sampling. So head-based sampling is something where upfront all the traces are evaluated and we are getting all the statistics, like how many distributed systems it went through, what is the total count of traces, which is good. We get all the data. But the other form is tail-based sampling, and something that is recommended and up and coming. So with tail-based, we evaluate after all the traces are sampled. What that means is we do not take into account all the traces that come into our collector or our backend. When you are using tail-based sampling, we choose what's the most actionable trace that we want to retain. Let's say automatic instrumentation or manual instrumentation. Once you send all the traces, you might not want to see all the traces in your backend to dig through everything. So if you use tail-based sampling and choose what the spans or trace you want to retain, when you actually get to the part of analyzing your traces, you have the actionable insights rather than all the garbage or anything additional that's collected. So tail-based sampling is something that is recommended, even coming support for even third-party vendors, and that's a concept OpenTelemetry is working and collector already supports. Here's an example for tail-based sampling. Before we enable the tail-based sampling for our application, in the collector, when I add the tail-based sampling as active, and I see and I say what I want to retain and what are the policies, and if you focus on the chart on the right, in the middle one, so before we enable tail-based sampling and after, there is a lot of difference of how much traces have been collected. And if you focus on the chart on the right, we see that we are getting lesser traces. That means we have only valuable data. Now, collector can be deployed in two different formats. One is agent-based and another is collector format, which can be standalone. So with agent-based, it can be same as where your host application or service is living. It can be, you can deploy it using binary, sidecar, or daemon set. And it's easy to deploy, it's quick, it has low operational overhead because you're just adding it directly to your host. With the collector format, you can deploy it as part of a container or using deployment. With deployment and collector or standalone deployment, you get advanced options like tail-based, which I just spoke about, and you can scale it along with your Kubernetes cluster. So if you really want to scale your collector as your cluster or Kubernetes grows, you should choose the standalone collector option. Now, there was an update recently that Kubernetes operator for OpenTelemetry was released, and it is stable. So if you want to use operator, which is recommended way now, you can definitely use that. Here's an example of how we finally deploy it. All the instrumentation, all the design consideration, and all the collector configuration that we have seen. So we can use Helm chart, and we can install the operator using this command. Because of internet issues, I cannot show the demo. So the configuration file is available in the link. I'll be sharing the slides with you all. And once you have this deployed, you apply this operator to your Kubernetes. We can deploy it. Again, there are multiple deployment options. First one is deployment as part of the collector default. And there is daemon set, there is stateful set as well. And also, about 4 months ago, there was an API that went stable where sidecar auto injection is also available now for auto instrumentation. So if you really want to start quickly with auto instrumentation, you can use sidecar, which is provided by official OpenTelemetry SDKs. And here's a complete sample for YAML, a snapshot for you. We add the operator command at the top. We configure our collector of what we want to receive, what we want to process, and where we want to export. So individual configurations. And lastly, a simple example for Java application where we are using sidecar injection for instrumentation. It might not be visible to everyone, but I'll be sharing the slides where you can go through the complete file. So to recap what we have covered so far and what I've spoken about, we have seen the rise of OpenTelemetry, how the project is growing, and there's so much interest in OpenTelemetry, modern standards, and enhanced strong modern observability. We have seen the design consideration. Remember the cake example, auto instrumentation or NR agents, which is ready-made cake, and OpenTelemetry, which is customizable, where you are the master chef and you are in control. And we have seen OpenTelemetry instrumentation. We have seen the different concepts, SDKs, APIs, and as well as the nomenclature for semantic conventions and the OTLP protocol. We have seen the collector, where collector, how we can deploy and what options collector provides us. It has 3 components: receiver, processor, and exporter. And you can pick and choose how you want to deploy it, stateful set or deployment or sidecar. Lastly, we have seen how we can actually deploy it. I have added the GitHub link and the configuration file, which you can play around with. And it's an exciting time in the open source world with OpenTelemetry. A lot of interest, a lot of adoption. In the first slide that I showed, there are a lot of customers of New Relic who are already adopting OpenTelemetry, and we are seeing exponential growth and ingest with OpenTelemetry data. You should be mindful of adopting OpenTelemetry, going back to the design consideration. Plan ahead. If you have new application or you're re-architecting, include it in your plan already and answer those 6 questions before you start it. So be mindful of what language or what services you want to use OpenTelemetry for. And just having telemetry data is not observability. Like I mentioned, only with metrics and logs you cannot have observability support, and you cannot solve all your problems. So you need to understand all the metrics, logs, and traces individually and how they play together nicely when combined together. Now, deployment of OpenTelemetry has become easier as we saw official support for sidecar injection as well as Kubernetes operator. So if you want to get started quickly without worrying of how to deploy, those support is also available. And as a part of New Relic, we are heavily investing in OpenTelemetry. We are one of the top contributors in OpenTelemetry. Yes, we are vendors, but we are pro open source and we play very nice with OpenTelemetry. And we are one of the top contributors because we believe in data and not opinions. Thank you. I'll be at my booth if you have any questions. I can take one question. I believe I have time. But if you have any specific question, we have a booth here. You can come talk to us. Also, you can scan, you'll get the slides. There are some labs, self-paced labs that you can use at your own time. It's totally free. You can explore the OpenTelemetry concepts and also observability in general and how it plays around with your applications as well as Kubernetes. So we have multiple labs. Please scan through that and you can do it on your own time. You can also reach out to me. There are my social handles. If you have any specific questions to New Relic, OpenTelemetry, or anything in general if you want to reach out to me. Thank you. One last thing. We also have a competition running in our booth where you can win an iPad. Just play a simple game. Please visit us. It should be a fun game. Thank you again.
Thank you, Zameer. Your talk was not only informative but also thought-provoking.
Thank you.